genetics and chromosomes, the environment, genetics and epigenetics. This isn't a science class or biology, although I strongly recommend taking those types of classes. This is once again focused on the growth and development of children. So we're just talking about some of the important issues of human biology as related to how children learn, grow, and develop. A lot of times people ask, why are we studying children before they're even conceived? So we're kind of looking at the idea of both your genetics and your environment. That age-old nature versus nurture argument, the environment that the child is born into matters a lot, as does their genetic makeup. And when we're looking at environment, we're looking at our socioeconomic status, we're looking at our family makeup, your race, ethnicity, culture, the languages that you speak. All of that is going to play into who you are as you grow up, as will the genetic makeup that you also receive. So we have genetic makeup that give us some of our physical characteristics, and they also give us some of our personality traits and abilities as well. So if you think back to growing up, maybe you have I definitely have my dad's widow peak right here. And then I can roll my tongue, things like that, that my mom can do. So probably thinking back, you can think of, oh yeah, I have my sense of humor from my grandpa, or I have attached earlobes like my cousin, something like that. We are going to look at the ideas of conception though, and just basic biology 101. When you have a sperm and an egg, they combine, they make a zygote, which is just a single cell. So the tiniest, tiniest, tiniest of little single cells, which then reproduces millions and millions of times. That makes the cells of the newborn who is born. So it goes from the tiniest, tiniest of the smallest cells, reproducing so many times until we get a little newborn at the end. So this really is just also the idea of gametes, which are male and female cells right up here, that when fertilized, engage in sexual reproduction to make a zygote. And in our human makeup is our DNA. So what we have is 46 chromosomes, and it's super, super, super long. If we were to take DNA and stretch it out, some of it can measure up to 6 feet tall. So for some of you who are 6 feet tall, imagine all the DNA that are in our bodies and that our babies have and that are growing are big enough to be as long, if stretched out, as like a human man. So why we are interested in DNA as far as child development, it's very, very important for how we grow and learn, and scientists are deeply concerned with DNA research, trying to combat diseases and cancers and things like that. We care child development wise in that this is part of who we are growing up as well. And we also have pairs, and that's typically how our chromosomes are kind of made in our body and in our DNA strands. And we'll talk more about what can happen when some of those DNA pairs or those DNA strands have some issues with them. But a lot of this is the genetic transmission that we get from our parents and from our families. So you typically have a dominant and recessive transmission. So I just talked about tongue rolling, which is the ability to go, So that's a dominant transmission. We have earlobe attachment. So if your earlobes at the bottom are attached like this, or if they're loose like mine is, one of my twins has loose earlobes and the other one has attached earlobes. So it can be even different in fraternal twins like I have. Pinky shape, arm folding. If you just try to fold your arms right now, I'm always I'm a left on top. A lot of people are right on top. Do you have cheek dimples? So when you smile, do you have dimples come out? Do you have a cleft chin, the little indentation on your chin? A hitchhiker thumb, which is kind of a thumb that's bent out. Your toe length, like my third toe is bigger. My third toe is bigger than my second and first toe. And then I also have a widow's peak as well. So some of those are there. If you have a widow's peak, for me, it's a dominant trait, and it would be a recessive trait if I didn't have one. So these are my twins when they were much younger, but my husband and my father-in-law both have a cleft chin and I don't. One of my twins, the oldest twin right here, it's a bad picture, but she has a little cleft chin, and then other twin does not. So one twin got the dominant gene for cleft chin, and one twin got the recessive gene for smooth chin. Why do we care about twins? We actually do a lot of studies on twins. I talked in a previous lecture about going to UCSD with my twins when they were little and doing some studies on them, especially about eyesight and perception. But we like to get identical twins because their DNA, as I talked about before, that really long strand, are much more similar, and their genetic makeup is very, very similar because they were one egg that then divided. I have fraternal twins, which are two eggs that were fertilized at the same time. So they're basically just like sisters who shared a womb, whereas identical twins were one egg that then split. So they share genetic makeup. We like to study both sets of twins because if we have identical twins that are more alike on a trait than fraternal twins, then we might see that hereditary issues, DNA, things like that are coming into play. So if all twins were showing it, we could see if it was environmental, is it hereditary? So that's why they like to use both monozygotic twins, which is identical, and dizygotic twins, which is fraternal. I'm lucky in that I have my adorable fraternal twins over there. And you can even see they both have dimples, which is a dominant trait that they both got from my husband and myself. A fun activity would be 23andMe. There are those DNA swabs. You put a swab in your mouth, you send it out, and you get to know where your ancestors came from. Like my sister did it, and we were really surprised that we're like 4% Scandinavian, and we had no idea that we ever had like a Scandinavian grandma back somewhere in history. We're primarily, Irish, Dutch, things like that. But 23andMe, the company that does that, I'm not saying don't go out and spend the money, but they have some really fun little videos about genetics and games you can play. So if you wanted to know more about this topic, 23andMe has some fun games that you can play. Now, getting back to that idea of DNA, there are genetic and chromosomal abnormalities or defects. And then in science and medicine, they call them abnormalities and defects because they're trying to prevent those things from happening in our genetic code or within our chromosomes, our pairs, and part of our DNA. In education, social services, kind of the field that I'm in, we typically call them special needs, delays, exceptional needs, or typical versus atypical development. We don't typically see these changes in your chromosomes or your genes as an abnormality or a defect. We're just seeing it as part of who you are as an individual. We also want to understand and know if you're going to have any changes in your chromosomes and your genetics, because then we can set you up from teaching and coaching and support from the very beginning. I used to work with children with special needs, and we start early education and early support for children with Down syndrome as early as 6 weeks after they're born. They're gonna have some delays over their entire lifespan, and the more that we can get that education started, the better it will be for long-term growth and development. We have lots of identifying and testing that we can do to find out about if any of those disorders within your genes or your chromosomes are part of the prenatal development of the baby. Once again, it's a really important thing that we notice. We want to know if like a child has something like Down syndrome, because a lot of times there can be heart problems right after the baby is born. So typically, if you're going to be delivering a child with Down syndrome, you want to be at a really good NICU. Like here in San Diego, it would be like Sharp Mary Birch. I think also Tri-City has a high level, and I think Palomar does as well. In Orange County, you've got Chalk, the Children's Hospital, and then in Riverside, it's Palmerado, I think. But all of these places have really good NICUs because sometimes babies who are born with Down syndrome need to go into heart surgery soon after birth because they're having some issues with heart valves and heart issues as well. And so we want to make sure that we know if a child's going to have a genetic or chromosomal disorder so we can set up that birth plan, make sure that you get to the right hospital where you need to be so we can take care of baby as soon as possible and as appropriately as possible. Typically what you do when you're pregnant is you have ultrasounds, and I'll show you a picture of what an ultrasound looks like in a minute. And an ultrasound is just kind of a wave machine that you can put on your belly, and it will show you what the baby is looking for. We're typically looking at the back of the neck, we're looking at the bone development, we're looking at the brain development, how many chambers there are in the heart, what the kidneys are doing, because we can even see the output of kidneys. And so those types of testing with ultrasounds can tell us a lot about the baby and how the baby is developing. It can even tell us about fluids. So if you were losing a lot of the fluids that you need, the amniotic fluids that you need around baby, then we can make sure that we could get you treatment for that. They now actually even have surgeries for babies. They did one just a little bit ago where they actually took the baby out of the uterus, repaired the heart, and then put the baby back in to the parent, back into the uterus so that the baby could continue to grow. So we're getting some great things, but we need to know that baby has this first to begin with. Some genetic and chromosomal disorders will be present, but they won't be identified until toddlerhood or even into adulthood. Some of these things, like your heart, like if you have a chronic heart problem, a lot of times you won't even find this out until middle childhood or even later into adulthood as well. There's genetic counseling as well. So if I had a dominant marker, and my husband had a dominant marker for like cystic fibrosis, we might want to look at adoption or embryo adoption, egg donations, things like that, if we were both probably going to give the child cystic fibrosis, which is still kind of can lead to death early in adulthood as well. There's lots of other testings that we can do, amniocentesis, CVS, and then depending on your family history, a lot of Italians, African Americans, and Eastern Europeans will also go through genetic testing if they have a higher propensity for having things like sickle cell or other kinds of genetic conditions. Once again, you could go through genetic counseling. This is all something that you would do with your pediatrician, your genetic counselor, and any kind of obstetrician or gynecologist that you have, because they have had all of the amazing training and can make sure that your pregnancy is as healthy as possible. Now, we talked about all of those chromosomes, so those pairs that make our DNA. So we've got these chromosomes, and Down syndrome, which I have worked with so many children with Down syndrome, and they're wonderful children, and they just have an extra chromosome. So right here, instead of it being a pair, there's an extra one. And that's why I put this adorable picture of this little girl, because her shirt says, I'm rocking this extra, am I rocking this extra chromosome or what? So kind of playing on the fact that she's got some extra material that's making her extra awesome. So we don't have a specific cause, but we do know that advanced maternal age really is a factor when it comes to if you have a child with Down syndrome or not. In your early 20s and 30s, it's 1 in thousands for having a child with Down syndrome. Once you're 49 and in your late 40s, it goes up to, I think, 1 in 12, 1 in 15 chance of having a child with Down syndrome. So we do know that maternal age and your egg quality has something to do with it, but we can't predict if you're going to have a child with Down syndrome or not. They definitely, and I talk about Down syndrome because most people can recognize a child with Down syndrome because they really have noticeable facial features. They typically have really beautiful almond-shaped eyes. They also have some differences around their nose as well, their nose bridges. So typically, if you see somebody, you can see and tell if they have Down syndrome or not. Once again, that is definitely a birth that you would like to have and need to have in a hospital that has a NICU, which is a neonatal care wing of a hospital, because once again, there can be heart defects and there can be some feeding issues as well. So making sure that babies can nurse really well when they come out is a really great reason to have like all of your doctors and everything at a NICU where they can take care of you and the child. And then leaving the hospital, make sure that you have your early intervention and you also have advocates. So we have this idea of epigenetics, which is a newer field that we've kind of been exploring in the last couple of years. And it is a, all right, so the idea is above genetics. So the that's the actual term for epigenetics. But what it is turning on or off genes that determine the functions of cells. So we all have the genetics that we're born with, but then how we are raised and our environment changes our cells as well. So the foods that you eat, the interactions that you have, hopefully with people that are positive and fun and loving and attached, drugs that you can take, exercise that you have, if people around you take drugs or you take drugs, all of these can determine the functions of cells. So we've done this primarily with rats. And what we did is we had two kind of sets of rats. And a good rat parent is a licker. So they lick their babies. And you've probably seen that with like dogs or cats when they're first born. The parent of the little puppies or kittens or baby rats licks them a lot. And that is a sign of really good parenting in our little rats. That means that they're bonded, they're attached, their physical well-being is taken care of. So we took two different types of rats. We took rats that had great licking parents, and we took rats that didn't have parents that didn't lick them. So rats that were being parented well and rats that were being parented poorly. We took the babies and we switched them. So we had the rats that were born to the good parents, and we had the rats that were born to the poor parents, and we switched them. So we switched the genetics that they have, and we put them into two different environments. The rats that had poor parenting genetics, but were raised with great parents, showed changes in the genetic makeup that they have. So their cells were changing because they were being raised well. They were being bonded, they were being attached, they were being loved. Physically, they were being taken care of. And this wasn't only just changing their personalities, it was changing their cells as well. And then the rats who had great parenting genes, we put them into low environments where they were ignored and they weren't loved and they weren't licked, and that changed their cells as well. So we're really interested in this as child development professors, because we really see some of this. We see that environment and in genetics are so intertwined and so important for how children grow and develop. So in conclusion, genetics and environment are interrelated. We bring as parents, I have 3 daughters. I brought my genetic makeup and my husband brought his genetic makeup, and it's all together for combining it together to have a child that has both of our genetic makeup. It gives us some of our physical and our personality and characteristics and our abilities as well. There are some issues when it comes to that as well. There are chromosomal differences and genetic and hereditary disorders that we also need to be aware of so that we can make best plans for when children are born. And then once again, the idea of epigenetics, if this is interesting to you, there are some really great videos on YouTube that will really kind of get your interest. So check them out. I will see you guys online.